pieces and parts of a piecewise function that we started to look at on Friday. So definition, it says the graph that's down here, both the equation and the picture, is called a piecewise function. So piecewise, I always want to write it as one word, but word processor always underlines it like they like it as two words. I don't care. Piecewise function. One word, two word, I don't know. So a piecewise function, we saw a little bit on Friday, takes pieces and parts of different graphs and puts them together into one function. Now, this example down here, this graph that's below, appears to be made of 3 segments, right? How do I know it's a segment? Refresh your geometry for me here. Yeah, there's 2 endpoints on the line, right? So there's 3 lines with 2 endpoints, so they're all line segments. Now, the piecewise functions have function notation f of x, and then it has these curly brackets. So that's saying it's like a set of these 3 equations. The first 3 things you see are equations of lines. F of x is like a y equals, so it's like y equals x plus 7. That's typically the graph that's farthest to the left, and then the middle, and then the right one. Okay? So each piecewise has an equation, a comma. After the comma goes the domain on which the graph, or the piece of the graph, is created. So if I look at this left section here, we always write the domain, I should say, as an inequality within the function. So what is the domain of this left piece right here? -6. Now there's a closed dot there, so what symbol goes after the -6? Less than or equal to x. And the domain goes until what x value? -3. Oh, and I forgot my symbol. That's a less than because it's an open dot. Right? That would be the domain on which the graph x plus 7 is graphed. Right? I didn't graph the whole thing. I just graphed that little piece of it. All right, then I have my next graph. Y equals 2. That's a horizontal or constant function here. What's the domain on which that piece is graphed? -3. This one has a closed dot, so less than or equal to x. And it's less than 4. And then the last one, the graph y equals -2x plus 14. That's this last section. What's the domain on which that line is graphed? 4. Closed dot, less than or equal to x, is less than 8. Good. Now let me ask you before we do the domain and range of the entire graph. Is this a function? How can I tell? Just say it. Passes the vertical line test. Now what about these points right here? Because I have 2 dots at both those values. Just say it. It's fine. Yeah, one's an open dot, one's a closed dot. So that open dot in both of these spots does not have a value. It's a placeholder. So technically the vertical line only passes through the closed dot. So it is a function. Is it a one-to-one function? No, because it would fail the horizontal line test. Good. Okay, so domain and range of the entire graph. So this one, I'm going to use interval notation for. You could use inequalities again, but I'm going to use interval notation for the whole graph. What's the farthest to the left part of our graph here? -6. Okay, so I have -6 with a square bracket. And if I trace through the whole graph, I have a point, I get to this open dot, but then there's a value at -3, so my x's keep going. I get to open dot, but there's a closed here. And when do I stop having an x value? 8. So comma 8, that's an open dot, so I have a parenthesis. Same kind of idea for the y's. The lowest y here is at -2. There's an open dot. So a parenthesis, and that graph goes up until 6. Is there anything higher than 6 on the rest of the graph? No. There you go. We'll get some weird looking ranges and domains in a little bit. Okay? Easy, right? So your domain is how you know what piece to graph. So let's look at one more here, and then we'll get to the graph in part. This graph is made up not of segments, but of 2 rays. What is a ray? This line that has one endpoint and an arrow going to infinity the other direction. So let's talk about the domain of each of these rays. Right, so I have negative x plus 4, that's this left one. How would you write as an inequality the domain of that left ray? Are those x's bigger than 3 or smaller? Smaller? Smaller, so you'd say x is less than 3. That is the domain on which that piece of the graph is created. What about the ray on the right? What's the domain for it? X is greater than or equal to 3. Right? I don't have another endpoint because it goes to infinity. So what would be the domain of this entire graph? Negative infinity to infinity. Okay, what about the range? What's the lowest y value? 1 with an open dot. And how high up does it go? Infinity. Okay. You guys understand the parts? Let's do some graphing. So we're going to do 3 or 4 graphs together. The first couple we don't really need our calculator for, but then we will start to use our calculator. I'm going to try to show you some techniques, some strategies, and some kind of rules to follow as we go through here. So now let's talk about equation and graphing. So I have a function here. F of x is created of this piecewise function. How many equations are we going to graph? 2, right? There's 2 equations. And I made a big table. And I said, for the first equation, 2x, I'm going to use these points to plot. Okay? And then for the second equation, I'll use those 3 points. So let's start with the first one. I want to, why do you think I chose these x values? -5, -3, 0, 1, 2. Why did I choose those x values? What do you think, Kayla? Yeah, they have the endpoints of the domain, -5 and 2, and then some numbers in between. Okay, so if I were to put -5 into this x value, -5 into the function of f of x up there, I don't know where that came from, but turn it off. So I have 2 times -5. What's my output? -10. And you can do this in your head. I'm just showing you that I'm taking -3 and putting it in for x in that function. So I'd have -2 times -3, which is -6. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2? 4. Okay. Now I have those points. Let's talk about how we're going to graph this really quick. At -5, I have a less than or equal to symbol. What kind of dot will that cause me to graph? A closed dot. So at the point -5, -10, I'm going to have a closed dot. At the point 2, 4, what kind of dot am I going to use? Open. And because there are 2 numbers in my domain, will this graph as a ray or a line segment? A line segment, right? I have 2 endpoints, so I'm going to connect them once I plot them. So let's graph these points. I have -5, -10. That's a closed dot. -3, -6. 0, 0. 1, 2. And then 2, 4 we graph as an open dot. And I'm not going to be too worried about precision here. Just kind of connect them the best you can. I know I didn't hand out rulers. I can give them if you're really concerned about it. But that's our line segment. Do you agree? Do you look okay? All right, now we talked a little bit about this next one on Friday, the 5. That is like y equals 5. So for this whole function, there's no x there, so we're not multiplying by x this time. What's going to be the output for all of those x values? 5. And when I graph this, what kind of line does y equals 5 graph into? I know there's a 6 too. Horizontal. Okay, so when I look here at 2, what kind of dot's going to go at 2, 5? Closed. What kind of dot's going to go at 6, 5? Closed. Now again, there's 2 numbers in my domain, so it's going to be a line segment that connects between those 2. So I'll plot 2, 5 with a closed dot, then 3, 5, 4, 5, 5, 5, 6, 5 has a closed dot, and I connect them. So that is your piecewise graph. Now we have a couple ask you these questions every time, just once to kind of get you thinking about it. So we answered the first one. How many pieces of their graph did you have? You graphed how many pieces? 2. Why did we graph 2 pieces? Because there were 2 equations. Now, are those pieces, I know we've talked about this, but are they rays or segments? They were segments. How could you tell they were segments before you even graphed them? Yeah, the domain, these inequalities right here, the domain had endpoints, right? 2 endpoints of the domain. So I would say there were 2 numbers in both domains. 2 endpoints for the domain. Now, when we graphed it, were they all solid dots, all open dots, or some of each? Some of each, right? We had some open, some closed. You have to look at the inequality symbol to tell the difference. Okay? Now, when I made this graph, was it necessary to use every single point that was in this table? No. Okay. So, no, I made you do extra work. Which points should we have condensed it down to? Just the endpoints. Now, the endpoints, what does that mean? Where would you find those endpoints? The numbers in the inequalities, the numbers in the domains. So you only need, for this one, you really only needed to use the, I'll say endpoints because that's, you guys know what that means. But endpoints, that's the numbers in the domain. Those are the key points. And I guess that kind of answers that question. 5 and 6 we get together. So let's speed up the next one, and then we'll ramp it up a little bit. So now look at the next one here. We can try this on our own in a second, but I'll get you started. I have 2 equations again, right? Is the first one going to be a ray or a segment when I look at the first one here? A segment. How can you tell? It's got 2 numbers. So what 2 numbers should I put in my table to plot? -8 and 1. Okay. So when I connect those, the -8 is going to have a closed or open dot. Closed. So 1 is going to have an open dot. And I'm going to connect those to make a line segment. Then I look at the next one. And I'll let you work ahead in this, or work on your own here in a second. Is that a ray or a segment? It's a segment. Again, because there are 2 numbers. So in my table, what 2 numbers do I put? 1 and 7. And you don't have to skip a space. I'm going to skip it just to visually separate them a little bit. All right, 1 will have a closed or open dot. Closed, and so will 7. So I can connect those when I graph them to make another segment. So take a couple minutes here. I want you to figure out what would be the y values and then make your graph. Okay, so take a minute, do that, and then I'll come back. I'll have a graph for you too. Then we'll check our work. You should have a graph that looks kind of like that one. Not too hard, right, so far? Line segments are easy. Let's talk about domain and range down here. Do I have any questions so far? Okay, now I have a couple questions here, and then we'll just graph from here on out. Was it necessary to evaluate both equations, both pieces of the function, for the x value of 1? Why? Yeah, they have different y values, but here's the thing. When I look at the inequality here, oops, I'll use this color. This guy has an open dot, and this one has a closed dot. Why do I still have to use 1 for the top equation? Why can't I pick something else? Like, why do I still have to use 1? It's not even included in the domain. That's where the graph's ending. Because technically, 0.999999 is in the domain, right? So I need to visually show that even though 1 isn't in there, that's where the graph is going to. I have to put that open dot there. Okay, so just because it's less than, you still have to put a value for the graph at it. Okay, so yes, we have to include it. The critical values were the endpoints, right? We talked about that before. All right, let's do domain and range here. What would be the domain of this entire graph? -8. Okay, so I'm going to write it up here just so I don't have to move the graph so much. -8 inclusive. And yeah, I go till 7 with the closed bracket. Do you guys agree or disagree? Agree? Okay. What would be the range? Where's your lowest y value? -5. Okay. And how high up do you go? 8. Okay. Let's open up our calculators. We're going to need them for the next one. So we've done 2 graphs where we had just lines and line segments. Not complicated. The next one's going to be a little bit different. Now, it says this on the words here, and I'll talk about it as we go, so I don't have to read it for you. When I look at the first equation, highlighted in yellow, when I look at that guy, when I graph it, is that going to be graphed as a ray or a segment? How do I know it's going to be a ray? Because there's only one number in the domain. So when you are graphing these piecewise functions, when you are graphing rays, like this first one, or equations that are not lines, this is going to be a parabola, I need you to plot as many points as possible that will fit on your grid, because you need to accurately graph the whole thing. You can't just sketch it or draw an arrow off to the side. So we are going to need to look in our calculator and figure out how many points do I need to plot on my grid. So for a minute here, I want you to open up your calculator and type 0.25x squared plus 2 into the y equals. Okay? So we'll do 0.25x squared. I forgot the x. Plus 2. So we'll use our calculator, we'll hit graph, and that's what the whole graph looks like. But what is the domain that we're graphing this over? X was less than what? -2. So I'm really only looking from like my hand over to the left. So let's go to the table. Second graph. And scroll through your table here. As I scroll through, I see where -2 is. So starting here at -2, 3, what other x values will also fit when I graph on my 10 by 10 here? Down to -5, right? So I want you to copy from your calculator from -5 to -2 onto your table. Those are all the points we need to graph to fit on our grid. So we'll have -5, -4, -3, and -2. Okay, so take a minute. It's on your calculator as well. -4 is 6. And then 4.25. Okay, so we're going to have to plot 4 points of this ray and parabola, right? Because it's a ray and because it's a parabola, I need to plot all the points that'll fit. Now it's a ray, so what kind of dot is going to go at that endpoint of -2? Open. And then from here on out, once I plot them, I'll connect it and draw an arrow on the end because it's a ray. It's not stopping at -5. So let's graph that. We'll have -2, 3 with an open dot. -3, 4.25. -4, 6. -5, 8.25. And you'll connect that to kind of look like a parabola. You have to put the arrow on the end because it's a ray. Right? Don't stop at -5, 8.25. That's the first part of the graph. All right, when I look at the second equation, 2, is this a segment or a ray? It's a segment because there are 2 endpoints. Now, it's a segment, so I have to decide. Does this graph as a linear function or something else for 2? It's linear, right? So when it's a linear function that is also a segment, all I have to plot on my table are those endpoints, -2 and 1. So I'm just plotting the endpoints here because this is going to be a straight line that's easy to connect. So what is going to be the output for both of those? 2. All right. Now at negative 2, I'm going to have a closed dot. At 1, I'm going to have an open dot, and I'm going to connect them. So you can go ahead then and plot those points and make your segments. And that one's a little bit faster because it's a line and because it's a segment. All right, now the last one. Is this last function a ray or a segment? It's a ray. Again, because there's only one number. Now, it's a ray. So because it's a ray, you need to plot as many points as will fit on the grid. Okay? Because we need to we can't just do the endpoint and then guess. We have to plot it accurately. So we have the x of 1. So if I put 1 in for x in there, what's negative 2 times 1? Negative 2. All right, let's put 2 into the function. 2 times negative 2. Negative 4. 3 times negative 2. Negative 6. 4 times negative 2. Negative 8. You could do 5, negative 10 if you wanted. At that point, you probably see the pattern. All right, and what kind of dot's going to go at 1? Open, and then I'll make a ray. So when you plot those, 1, negative 2, 2, negative 4, 3, negative 6, negative 8, negative 10, and connect them, just make sure you put an arrow on the end. So for rays or non-linear functions, we have to plot as many points as will fit. Okay? Get the graph? This one too hard to do? So my domain here, let's see, what's the domain? This one's going to be different. What's the domain from the left? Start on the left. What do we have here? Negative infinity. Nope. Not this time. So this one comes down. We have a closed dot here at negative 2, but I come over to an open dot. So I look down here. I also have an open dot. What x is not in my domain? 1. So I have to go up to 1 and put a parenthesis. Then we learned a symbol, or I showed it to you, that there's this union, because I'm joining together with another domain for the other half of my graph. Where do I start this part of the domain at? Still 1 with a parenthesis, right? I'm not including 1, that's why there's a parenthesis. And then it goes to infinity. Now there's another way I could write this that's shorter if I wanted, because what's the only one number not in my domain? 1. So if I wanted to, I could do set notation and say all the x's where x is just not 1. I could do that too if I wanted. I don't really care what notation you use for domain and range here as long as it's right. So whatever makes you happy. All right, range. Where do I start on the bottom here? Negative infinity up to negative 2. And then, oh, that's an open dot, so it's a parenthesis. And then I have some space, right? Are there any y values in here? No. So I have to join it together with, what's the next thing in my range? 2, but is 2 connected to this parabola up here? No, so when I have one number, and I'm doing interval notation, I use squiggly brackets. It's a little weird, but just 2. So I'm joining that negative infinity to negative 2, then the y value of 2, then, what's the next part? Because I have a little break again, it's hard to see, but a break. What's the rest of my infinity? Or the rest of my range, I'm sorry. 3 with a open dot to infinity. Ooh, kind of funky looking. But that's it, that's your range. Alright, I think we have one more. Yes, okay. Again, this one has some different graphs. I'm going to show you on your calculator graphing. We have like absolute values and stuff here. So the first one, is this going to be a segment or a ray? A segment. Okay. So when I look at that first equation, it's going to be a segment. Now, is that a linear function? Would it graph a straight line? What do you know about absolute value? What does the parent function look like? It looks like a V. That's not a straight line, is it? No, I mean, it has straight lines in it, but it's not a straight line. So because it's not a linear function, I need to use my calculator to plot all the key points. And those key points, I'm guessing, are everything between negative 8 and negative 3. So, oops, over here on your table, You need to plot -8 to -3. And then I'll show you how to do this on your calculator. And eventually, I'm not going to give you tables, like you can make your own tables eventually, but today I made them for you. So on our calculator, when we go to the y equals, it started with a negative, right? Negative absolute value of x plus 6. Does anyone know where absolute value is? Where is it, Nina? What? Do you know where it is on the calculator? Oh. No? Okay, you hit math. Do you know where math is? Math is the button right under the alpha. So hit math. Then I get a big screen with a bunch of stuff. I'm going to use the right arrow to arrow over to number. And then it's the very first option. ABS is for absolute value. When you click enter on that, it'll either give you 2 absolute value bars or it'll write the word ABS parentheses. Right? Inside there, I'm just going to type my x. Is it x plus 6? Or minus x plus 6? And then I arrow out of the absolute value bars. And is it plus 2? Yep. So when you hit graph, there's your picture. Yes. Be under menu and then number. Oh no, there's actually absolute value bars. Here, I'll come back and show you in a second. But if you click, it's one of the little things on the right under there, control, and then it's one of the symbols. I'll come back in a second. All right, so let's look at our table then. So we want to scroll through our table here and plot all those numbers from -8 to -3 here. Okay. We'll plot those. I forget already. I just looked at it. 0. 0, 1, 2, 1, 0, negative. And then you can plot that over here. So -8, 0. And -8 will get a closed dot. And an open dot at -3. So you can see it's a piece of that absolute value. Did you find it, Stephen? Okay. Now, is this second one, I'll do it when we're done with this one, Stephen, okay? Second one here, is this array or a segment? Second equation. It's a segment. Okay, so the second one's also a segment because there's 2 numbers. Is that a linear function? Yes, that's linear. So I only need to plot the -3 and the 1. Then I can just connect them. So I'll have an open dot at -3 and a closed dot at 1. What's -3 plus 4? 1. So -3, 1 is a point. That's an open dot. And then 1 plus 4 is 5. So 1, 5 will have a closed dot, and I can connect them. All right. Then the last one. Is that a ray or a segment? It's a ray. Now, is this linear? No. So since it's a ray and it's not linear, I need to plot all the points that'll fit on the grid to make the shape. So let's type square root of x minus 1 into my y equals. You know what the square root graph looks like, so you at least know what the shape generally will be. So let's look at our table. Let's figure out what points are going to work. We at least need to include 1. So 1 will work. Now I wouldn't plot all those decimals. Which points are going to be the best ones, do you think, to plot on my table? 1, 2, 5, and 10. So 1, 2, 5, and 10 is what I would plot. And that was 0, 1, 2, and 3. So I'm going to do all the decimals, just the next ones. Let's see, we have 1, 0 is going to have an open dot, and then a ray. So 1, 0, 2, 1, 5, 2, and 10, 3. And there's your graph, there's your ray. Not hard, just a little bit slow and tedious, right? Tomorrow we'll have one more day of notes. We'll be writing, so you'll get pictures that look like this, and you'll have to write the piecewise function. Not quite as complicated as this one, but there'll be some absolute value, there'll be some square roots, throw some parent functions on there for you. So there are 3 questions on the practice. I would like